Hello, my name is Andrew Perry, and today we're going to be talking about our CSE 212 interview question. We'll just jump straight into it. So, we're talking about linked lists today, and we're talking about how we're going to implement different functions using a linked list. So, we're going to start off with a stack. So, we have our tail, which is pointing towards the first value we put in, and the head, which is pointing towards the last value put in, assuming we put them in 1, 2, 3, and then each of the values points towards the next or the adjacent values. With our push, we're going to have a time complexity of O of 1, because no matter how long this array or this list gets, it's going to be the same operations to just add the value, create the pointers from connecting, in this case, the 4 and the 3, and then making sure the head points towards the 4. With the pop, it's going to be an O of 1 function, assuming that we're searching by index, or if we have it organized in a way where we can just have it pop the value and it doesn't need to search for it, or else it would increase our time complexity. But the operations for changing the pointers, and in this case the head not the head pointer, but the 4 and the 2 after removing the 3, that's going to be an O of 1 operation. Next, for our get top or peak, this is an O of 1 operation. All it does is it looks at where the head's pointing, it just pulls the value and returns it. And then is empty is also going to be an O of 1 operation, because similarly it just looks to see if there is a value at all. Now for our queue, we start off with a similar setup. And queue is actually going to be the exact same step-by-step for push. In this case the 4, and so that's going to be an O of 1 process. DQ is also an O of 1 process, and this one doesn't actually take any parameters because it's always going to remove from the tail, right? And so then we just move our pointer, the tail pointer, to the next value in the queue, and that's just an O of 1 operation. Now for the size, I didn't put anything there because there's two ways to go about it. I think in the interview question it says the optimal way to go about it, I think, would be to keep a variable in our object, in our queue object, to keep track of the size. So every time we pass in queue, we increase our size by 1, and every time we pass DQ, we decrease by 1. So that way we always have an internal track of the size. So we don't have to worry about counting, because that would be an O of n process, whereas just pulling the value would be O of 1. And then is empty, same thing, O of 1, and that is a lot of talking for a 3-minute video, but I hope you learned something, and I will see you later. Bye.